Hi everyone, welcome to my YouTube channel, and today we will be solving the question of partition list. So this is a lead code medium, and in this question we are given a head of a singly linked list. So the head is here, as you can see, and we are given this singly linked list, and we have to partition this linked list such that all the nodes less than x. So here x is also given along with our singly linked list, and here x is an integer. So here we can assume that linked list has integer values, and along with linked list we are given this integer x, and we have to partition this linked list such that the nodes which have values less than x are on the left of the nodes which have values greater than or equal to x. So here our partition list is something like this. So these three nodes here, as you can see, these have values less than 3, and these nodes here have values greater than equal to 3. And we have to partition the linked list in such a way that the relative order of the nodes in the partition is same as the order in the original linked list. So here the what this means is the order of so as you can see, the node 1 is here, node 2 is here, and node 2 is here. So here the ordering in the final linked list is also the same as the ordering in the original one. So here as well we have node with value 1 here, node with value 2 here, and node with value 2. So the ordering is the same. And here as well, for nodes which have value greater than equal to 3, so their ordering is also the same as the ordering in the original linked list. So here the node 4 is before node 3, and node 3 is before node 5, and in the original linked list as well it was in the same order. So let's see and how we can solve this question. So let's draw a few diagrams to understand this better. So here we have our linked list that we need to partition, and the given value of x is equal to 3. So the way we can solve this question is, first of all we'll have to iterate over the linked list. So to iterate over the linked list we can use a current pointer, and I can assign it initially to head, and then I'm going to need to save the next reference. And what I need to do is, when I'm iterating over the linked list, I can maintain two separate lists. The first list is the smaller list which has nodes less than x, and the second list is it's going to have the nodes with values greater than equal to x. So here what I can do is I can initially create the dummy nodes for my smaller and bigger list. So here let me assign it -1, -1, and what I can call this is, let's call it smaller dummy, and let's call this bigger dummy. And also when I'm iterating over my original linked list, I'll also have to iterate over smaller and bigger lists as well. So here I can assign my smaller dummy to another variable, let's call it smaller, and another variable here, let's call it bigger. So initially when I am iterating over my original linked list, so currently I am at node 1. So here value is less than 3, 1 is less than 3. So this node is going to go in my smaller list. So here what I can do is I can set smaller.next as current, and then I can set my current.next as null to break the link here, and that's why I need to save my next reference as well, because I'm going to update current.next. So here what I have done is, so the code is going to have checked something like this. So if current.val is less than x, what is going to happen? Smaller dot next is going to be equal to current, and current dot next is going to be null. And once I have done this, I can move on to the next element. I can update. So here what we will have is we'll have -1 and we'll have 1 here, and then I can update my smaller to smaller dot next. So my smaller would be here, and I can update my current to next. So my current will come to node 4, and my next will become node with value 3. And now we come to the node with value 4. So here this node 4 is greater than equal to x. So this is going to go in my bigger list. So here what is going to happen is -1 here, and then my bigger dot next is going to point to my current now. So my bigger dot next is going to point to this, and my current dot next I'll update it to null, and this would look like something like this, -1 4. And once I'm done doing this, I can update my bigger to bigger dot next. Bigger will come here, and I can move my current to the next element. So my current will move to next, and my next will be current dot next. And so far I have joined these nodes 1 and node 4. So far we have traversed till node 3. We're currently at node 3, and we have done processing the node 1 and node 4. So now we are at node 3. So node 3, its value is greater than equal to 3. So it's going to come in my bigger list. So it will come here, and next we're going to do the same thing again, move on to the next node, this node 2, and my node 2 is going to come here, and similarly we're going to update this bigger here, this smaller will go here, and what we are going to have at the end of the iteration, we're going to have our smaller list like this, -1 1 2 and 2, and my bigger list is going to be 4 3 and 5. So this one is smaller dummy, and my this node is bigger dummy, and at the end what we're going to have is my smaller variable. It's going to point here. What I can do is next is I have to join these two lists. So I'll have to set smaller dot next equal to bigger dummy dot next. I'll have to do smaller dot next equal to bigger dummy dot next, and after that we can simply return smaller dummy dot next, and it would return our partitioned linked list. So for the case when my linked list might only have 1 or 2 nodes, so in that case what it could look like is my smaller dummy would be this again, and it might not have any elements after I'm done traversing, and my bigger dummy might have some nodes. So in that case, my smaller will be already pointing here, and I'll be assigning smaller dot next again to bigger dummy dot next here. So that way we don't need to worry about null pointer exceptions because we are using dummy nodes. So this is another question where using dummy nodes is helpful. So this code covers all the edge cases, and yeah, let's dive into the code implementation to understand this better. So let's have a look at the code implementation of this problem. So here we have to implement this partition function. So as discussed from the from the algorithm walkthrough, we are going to need two separate linked lists, one for smaller nodes and one for bigger nodes. So for that, first I'll create two dummy nodes. So let's create those. So list node smaller dummy equal to new list node -1, and list node bigger dummy equal to new list node -1. And we're going to need two variables, smaller, and I can set it to smaller dummy, and another one bigger, and I can set it to bigger dummy. And now we can iterate over our linked list. So here I can use a current variable and assign it to head, and I'm going to iterate till my current is not equal to null. So like this, and what I'm going to have to do next is I have to save the reference to the next pointer. So here next equal to current dot next. So when I'm joining my current node to either smaller or bigger node, I have to set current dot next equal to null in both of them. So I can do it initially, current dot next equal to null, and then I can check if current dot val is less than x, then it is going to go in my smaller node. So smaller dot next is going to be current, and smaller equal to smaller dot next, and if it is greater than equal to x, then it is going to go in my bigger one. So bigger dot next equal to current, and bigger equal to bigger dot next. And next I can increment my current to the next node, which is already saved in my next variable, and I can set my current equal to next. And once I am done processing the while loop, I have to join the lists. So here smaller dot next is going to be equal to bigger dummy dot next, and at the end I can return smaller dummy dot next, and we'll be done. So let's try to run this. So yeah, that works, and let's submit, and yeah, that works as well. So for time and space complexity, this algorithm is O of n time and O of 1 space. O of 1 space because we are just reordering the nodes, and O of n time because we are iterating over our original linked list. So I hope this made sense, and I'll see you in the next video. Thanks for watching.